Okay, so we would like to do 12.1, number 26. What was your name?
Jordan.
Jordan. For Jordan. So we have, I dedicate this one to Jordan. So we have g, the acceleration due to gravity, at a distance h, from the center of a planet of mass m. Okay, so this sounds like space physics stuff, right? And frankly, I'm not that smart, but I do know what a planet looks like, right? It's round. That is actually part of the definition of a planet. It's not got enough gravity to round itself out. It's not a planet. It's a subplanet or something.
Asteroid.
Planetoid, I think, is the...
Yes.
Okay, so I have round thing. Good. There's some kind of distance. And they didn't actually tell me whether the, like, here's my object, right? They didn't tell me whether the distance is the distance from here to there or the distance from the middle to there.
This is from the center.
Center of gravity.
The middle.
Oh, good. From the center. Excellent. So it is from the middle to the thing. Cool? It doesn't actually matter much, but. So then they asked, if m is held constant, right, so the planet's mass is constant, is g an increasing or decreasing function of h? Decreasing seems reasonable,
Oh,
right?
the further it goes.
If you put this thing further away, this planet's going to pull on it less. How do I know that's true?
Physics.
Because I don't go flying into the sun, for instance, right? Because the sun is big, like way bigger than the Earth. Thankfully, I'm further away, so I don't get pulled into it. You guys see that? Okay, so part A, decreasing in h if m constant.
And if h is,
G is decreasing in h.
if h is greater than or equal to the radius. Because then you get weird stuff.
Yeah, I'm not really sure what happens if
It starts to
h is smaller than the radius of the planet, right?
It gets linear, I think.
Well, g becomes 0. The acceleration at the center.
Well,
At the center.
You get less zero than it's negative.
No, yeah, so things inside the planet are still accelerated
Yeah, but at h
towards the
equals-
middle. They're just balanced out by the force pushing out on the...
Yeah.
Yes, physics. Ask Anka or something. I might say that once in a while, by the way. If I say physics, ask Anka or something, that means I'm scared of saying something dumb on the camera. I will, if you want me to say something dumb, say so and I'll shut the camera off and say something dumb. It might well be wrong. So then our next question is, if h is constant, is g increasing or decreasing function of m? So what do they mean h is constant? What does that fix?
The distance away.
Yeah, that fixes the distance from the middle, right? And then is g increasing or decreasing as a function of m?
Decreasing.
So if I increase the mass, right, the acceleration due to gravity goes up, I think?
Yes. Yes.
Seems legit. Cool. Does that answer your question, Jordan? So really, I'm thinking kind of this way. If I had to write this out in function notation, I'm thinking g as a function of h and m, right? And then what am I actually considering here? I'm kind of considering, well, if I dump this variable, is this derivative positive or negative, right? If I dump this variable, is this derivative positive or negative? You guys all see that? So what we're actually doing is we're eyeballing the sign of partial derivatives, but you guys don't know those words yet, right? But you know what a tangent line looks like, right? So this I have some surface. This is not what a gravity surface looks like in general, right? Because gravity is an inverse square law. So it really looks like a, never mind. It looks like something. We could even figure out what the something is, but we won't right now. Okay, right? Handkerchief draped over thing. You guys all with me on the shape? And I told you not to draw it this way, right? Remember I drew it the other way the other day?
Yeah.
And this one looks worse,
Yeah.
right? Because I drew it backwards. So the thing you're getting at here is you're taking some, right? We're holding one of these variables constant. So if I had, say, m this way, and h that way, and g this way. Oh, well. I guess if I'm doing this, well, I should do this. Why did I switch those? Yeah, h is kind of in the x slot, right? So right-hand rule, which should say, right? This is not really here or there. But I should adhere to a convention, and so I'm going to try. Cool? All right, so if I'm holding, say, m constant, right? That's fixing something like this. You guys see that? Like, I fixed an m. And then I'm talking about h. And I found out that g is a decreasing function of h, right? That means that this thing in general goes down. You guys see that? So the tangent lines we're talking about are these ones. We're saying the slopes of those tangent lines are negative. You guys kind of with me? Where's the other one? Yeah, exactly. I'm fixing the other direction. And in the other direction, I'm saying that it's increasing, right? So I have something that kind of slopes down this way and up that way. You guys cool with that? Those are a little funny, right?
So would this one be on the H, facing the H way?
So what I did in the part A, right, was
Yeah.
I fixed M, so that's this.
Okay.
And I said if I increase H, G goes down. The other way is if I fix H, right,
Yeah.
then I'm finding that as I increase M, G goes up, right? So that's this way should be generally trending upwards. And of course, this doesn't match the handkerchief I drew, right? Because I just drew a rando handkerchief. And this thing's a little more specific than that. You guys cool with this? Questions, Steele? Does that help? Does the handkerchief help why they're asking those a little bit? Okay.
I just have like a basic question. So you're basically just looking at the cross sections.
Exactly.
Okay.
Yep.
Okay.
Yeah, so I'm taking a cross section of this surface, right? Like fixing an M or an H. And I'm not sure which cross section I'm taking.
Yeah.
But we could take even another cross section that's the horizontal one, right? We could fix a G and then look at the M's and H's that make that happen. That's that contour lining business that we started yesterday.
Oh.
That's what we're going to do today. Cool? Questions, Steele? No?